Hello, it's dumplet here. Here's an item on number theory. Prove that for all natural number n greater than 1, 136 times 137 raised to n plus 137 is not a perfect square. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, although we're asked for a proof that this number over here is not a perfect square, it's not that difficult to do. In fact, there's just one thing that we have to do, and we'll be able to prove that it is not a perfect square. Now, before we do that, let's try to make some analysis. The most common number that comes up is 137, and 137 we can first prove that it is prime. Now, what we have to do is we just check if 137 is divisible by numbers less than its square root by the sieve of Eratosthenes. So 137, so square root 137, we know it's going to be less than the square root of 144, and that equals 12. So what we have to do, we just check prime factors, or prime numbers less than or equal to 12. And let's see if it actually divides 137. So we can try 2. Well, obviously it doesn't. 3. Well, the sum of digits is 11, so it's not divisible. 5, it doesn't work as well. 7, it leaves a remainder of 4 when divided by, remainder of, 4 when divided by 7. And then when divided by 11, it leaves a remainder of 5. So 137 is actually a prime number. So we just include that in our proof because we're going to need it later. So the given condition where a natural number n greater than 1, that's the same as saying a natural number n greater than or equal to 2, since we're just dealing with natural numbers or positive integers. So let's take a look at this. Let this value be k. Now we can take two things. So first, we're going to take k under modulo 137. And since 136 times 137 raised to n, that's obviously divisible by 137 if n is greater than or equal to 2, and the 137 there is also divisible by 137. We can say that k is congruent to 0 under mod 137. Now the other thing that we have to check is, surprisingly, mod 137 squared. So since the first term is divisible by 137 squared, since n is greater than or equal to 2, we can see that k is congruent to 137 mod 137 squared. So we'll have these two congruences. And from these two, we can say that k is divisible by 137, but not 137 squared. So k is divisible by a prime number, 137, but not divisible by its square. So we can write this down using the prime factorization of k. Now, if we write down the prime factorization of k, since 137 is prime, well, we would expect there is a factor of 137, and we've concluded that it's divisible by 137, but it's not divisible by 137 squared, so 137 will just take the exponent 1, so just 137. And note how whatever the other factors of k are, it doesn't really affect our result. Why? Because from p sub 1, p sub 2 until p sub n, none of those are 137. So there are no 137s here. And this is a bummer for k because k cannot be a perfect square now. Just because there is a prime number, 137, that doesn't have an even exponent. Now take note, if we want something to be a perfect square, the prime factorization should only contain even exponents. Just for reference, if I have 12 squared, so 144, why can we say it's a perfect square? Because we can factor it into prime factorization as follows: 2 raised to 4 times 3 raised to 2. So the exponents are divisible by 2. But in this case, for k, we don't know what the other prime factors are, but we know for sure that 137 over here, it only has an exponent of 1. So this does not help with the fact that for a perfect square, we must have even exponents. So we can finally conclude that k cannot be a perfect square for natural numbers n greater than 1. And everything from the start to the finish, this will serve as the proof. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.